We are going to skip over a couple of the projects and go directly to project 7. So I'll go ahead and title this up here, YTAC project 07, and this is a magic 8-ball. It's a little bit funky with Tinkercad, as a lot of the things are, but it's still a good way, and this is a lot easier to kind of comprehend how it's working, because it's not really, it's pretty messy with all the wires. So for this is going to use a LCD screen, a liquid crystal display, 16 by 2, and to get this to work we will input a specific packet, so to speak, in order for that to operate. But that is, we'll get into that once we go on to the code. First things first, I want to create this circuit and get this operational. It is a little, like I said, it's a little hard with all of these down here are pins that you have to connect. Well, most of them anyway. So there's just going to be a lot going on. I will do my best to color code with all the wires, but before I do that, I'm going to quickly explain what, if you've lived under a rock, what we want happening here. It is a magic 8-ball. If you've never seen a magic 8-ball, basically it is a little ball that you shake it, and then a die that's in there that has different options will it'll surface in the water. So if you can see the stream here, here's what it looks like. You'd shake that and it give you some result. I mean, like maybe, ask again later, very likely, whatever. We're gonna do that here, but instead of it would actually, you would shake this breadboard, because we are going to start off and use a tilt sensor. We want to rotate it because just the orientation it is. We're going across here. I'm just going to put it on this side. I don't actually need this right side plugged in, or that top side, sorry. So I'm just going to connect that right here, get that power on this terminal 2 side. And that's where we're starting with the tilt sensor. If we start this simulation, you can kind of see it shows you this is straight, and then going over here to curved. Alright, so you have to shift it with this little slider, so you don't actually shake the breadboard. You would if you are doing this with a physical kit, but if you aren't, as always, no worries. Alright, so we're going to get a resistor on this side. You need to rotate it right here. Ohms. No, hang on, not 220. It is, yeah, 10 kilo ohms. So 10,000 ohms, 10 kilo ohms. That is by this, you can tell with this, the coloring here, the brown, black, and orange. I don't exactly remember how it works, but it's like you get the first 2 numbers and you multiply it by the third one, and then it's the degree is this like bit silver or gold. This one's gold. But we're going to finish putting this in here. I'm going to get a line over here, connect this breadboard, this tilt sensor, onto our Arduino. I'm going to keep it green to match this tilt sensor, because there's are going to be a lot of wires. Next thing that we're going to get here is we need to ground this tilt sensor. So I'm going to come right here in line with this terminal 2 of the resistor and plug it in to the negative bar, this negative column here. I'm going to change it to black as well, and then we're going to get a potentiometer here, and this will trigger the display on our liquid crystal display screen, how bright we want it to be. We need to set this up though, but nicely it says the pins here. This left pin on here, terminal 1, is your negative. Oh, excuse me, it's the positive. connect that right here, red wire. Terminal 2 is negative, connect that there, black wire. And then this middle one labeled wiper, we are actually going to connect this all the way down onto the breadboard. I'll make it blue because it matches that color. But this is going in the contrast section. Basically, this will be the text on our Magic 8 ball. That brings that brightness up or down. We just have a little bit more to do here on the breadboard. Right now we're going to grab this resistor. You don't have to do this on the breadboard, but I think it's a little easier to do so. It's coming from positive right there. And this is also going to be 10 kilo ohms. We're going to take a wire here, and we're taking this down to this LED anode. Anode is positive, cathode is negative. Basically, this is just saying the brightness of the screen. Because normally if you just connect this directly, it would be full brightness and you'd get an error message. This little tiny resistor here just allows that to be a little bit darker, a little easier to read. And if you had a physical LCD screen, it would be better for that as well. All right. I'm also going to connect the cathode here. I'm just going to bring that up to the ground, make that black, and that is our LED cathode and anode connected. I'm also going to go through here again and ground it. Just going to bring it up here, put it on the breadboard. I could connect it to the actual Arduino, but I like to have as little things connected to the Arduino as possible. Here's the power. Same story. I could connect it to that 5 volt directly on the board here, but I'm just going to take it up to the breadboard. We already have our contrast here. The register select is going up to 12, digital pin 12. This will make a little bit more sense once we actually get into the code on why these pins are here. But for right now, it's just going on that. Here on 11 is the yellow, and then read write coming up here, and this is just connecting to our ground. It's black. I'm going to pause right there, going pretty fast. Just kind of want to get through this circuiting stuff because there isn't really a whole lot of explaining to do. It's just sort of connect things where they go. It'll make a lot more sense once we get into the code. But that's one of the issues with the LCD screen is there's a lot of things here, especially with this particular project. So just a little recap. Oops. Cathode is negative, anode is positive. We have our enables connected to a digital pin. Read write is grounded. Register select is also on a digital pin. Our contrast is coming up from this potentiometer. And we have our power and ground again. This is for the board. This is for the LEDs. All right. We only have 4 more pins. We have all these DB0, DB1, DB2, DB3, DB4, going up to DB7. We are going to use 4 through 7. We're going to connect them right under the 6 on the 5. I'll make the first one pink. I'll make the second one going up to 4. We'll make that purple. The third one going from 6 to 3. We'll make that one turquoise. And then 7 going to 2. This will be, we'll go blue. Alright, and this is actually all of the wiring. This looks really messy. That's kind of unfortunately just the way it is right now with the setup. I could have probably moved this over here and it's maybe less so, but still not really. But with that out of the way, we're going to go ahead and start on the code. Like I said, this is the Project 07, so the Massimo Bonzi video produced by Arduino will show you the code, but I will walk through it my best. I don't have a funny Italian accent, but hopefully I'm not that horrible to listen to. As always, you could use blocks plus text, or you could just use text. I will be using just text because text is the official all the videos are on text, and I have bad nostalgia with Scratch whenever I go to blocks. Alright, so before we get into the setup or the loop, we need to define some variables, include a package specifically. Whenever we import, we're going to say hashtag include, and then liquid crystal. This is for that LCD screen, period H. Alright. So, we are going to go ahead and move on from here. We have this liquid crystal display screen that's now hooked up. That's what this is basically doing. And now we have a command liquid crystal, which we will use to write our words on. We're going to go ahead and start and define what liquid crystal we have. And it's hooked up to 12, 11. That's what these are over here. And then it's over here, 5, 4, 3, 2. 5, 4, 3, 2. We'll go ahead and use that semicolon. We usually do in C. Alright, and then we're going to go down. We only have one switch pin that is constant. And remember, we use the constant int. And we're just going to name this switch pin 6. This is our tilt sensor up here, where this guy is hooked up. Get off. Get off. Hang on. I don't know why this guy is sticking. Alright. Oops. Alright, just get this mess off. Or don't. You know what? That's fine. We're just going to leave that little spaghetti of wires there. But we have our tilt sensor is hooked up over there. And we're just going to go ahead and move on. If you're following along, please don't make a spaghetti monster like this. This is a complete accident. Alright, next thing we're going to do is we're going to have our switch state, this is basically going to be how we are finding the state of the tilt sensor. And this is going to be set to 0 initially, meaning no tilting in it right now. Then we're going to take another integer, another variable value for this. This is going to be the previous switch state. So basically we're going to have the 8-ball code. Oops. 8-ball code is going to say, in order to tell when you're shaking it, it's going to say what is it now and what was it, and then that will determine if it's being shaken or not. And then we're going to need one more variable, which is still an integer, reply. Reply is just what the screen will say once you have shaken it, and it wants to know what's your reply that you get from the magic 8-ball. First thing we're going to do, lcd.begin. This is now in the setup, 16,2. This is the size of our liquid crystal display, 16 characters by 2 characters, rows and columns, if you will. Because not in Tinkercad, but there are bigger liquid crystal displays, like a lot of monitors like that you are looking on right now are liquid crystal display. Excuse me. So we're going to get our pin mode here. And this is just determining what we have here. Switch pin, which is the variable 6 for our tilt sensor. This is an input. We want to put our colon there. Now, we're going into the LCD commands here, and the first thing that we're going to do is say, before we shake it, we want it to tell us what to do. So it'll say print. We'll just have it say ask the, and I don't think it'll all fit in one line, so I'm going to go ahead and go down another line, but in order to do that, I have to set the cursor down. So right now, it's starting at the position 0, 0. The column is by the first number, the row is by the second number. And remember, the first column is 0, the first row is also 0. Just like most programming languages, they start off on 0. So we want to change it to that second row, which means we're going to set the cursor to 0, 1. That's putting it at the 0 position in the second row. And we're going to go ahead and finish that LCD print. Ask our magic 8-ball. We'll put a little exclamation point because this guy's happy to have you. Perfect. Alright, that's all we have for our setup. All we really did was tell what our switch pin was, that it was an input, and then we set up our LCD screens. I think if we started it now, I don't want that void loop there. If we started simulation right now, it's not showing anything. It's because it's potentiometers all the way like that. There we go. So if you've done it right up to this point, it should say ask the magic 8-ball once you turn on your simulation. A couple little issues that might be, well, the main one would be if your potentiometer is turned off, you want it to be rotated as far clockwise as it can go, and then that will give you your magic 8-ball text available to you. Right now we haven't done anything with the sort of switch pin or tilt sensor or any of this stuff, so if your LCD screen isn't lighting up, that could also be because you have these wired wrong. But I will, after this lesson, if you still can't get it to work, I will link this project as well as the Massimo Bonzi video in the Discord. But I'm content. Yeah, there we go. Get rid of that. I'm content with my output here, so I'm going to move on into the loop. So the first thing that we want to determine is what is the switch state. We named the variable up here, but now we want to know what it is. So I'm going to take our switch state and I'm going to say that is equal to digital read of our switch pin. We've used this function before. Basically, it's checking that tilt sensor and it's saying, you know, what is it? How is it tilted? Is it tilted or not? To what degree? That sort of stuff. And then it's determining our switch state. And then we're going to have an if loop. This is going to be determined if it's being shaken. We're going to say if our switch state is not equal, exclamation point equal means not equal. If it's not equal to the previous switch state, that variable up here, then we're going to close this off, open bracket, and this is the next line, and then we're going to say if the switch state is equal to low, that double equal sign is saying if it is set to that. This is using the booleans. So remember, low is off, so not. There's high and low on the digital. So if it's the previous state is different from that and it's low, then it will do this next thing, which is saying we're going to start off and we're going to clear that LCD. We don't want to have that ask the magic 8-ball up anymore. And then we're going to give it, we're just going to have it give a random reply. So we're going to say reply, which we initialized up here. Reply equals random 8. So that is now 8 different random in the range of 8. First thing we're going to do is we're going to reset that LCD. We want to set that cursor. It's currently somewhere down on the bottom row. We don't want that. We want it to be set to 0, 0 again, so we can start writing. We're going to take our, go ahead and just snag this LCD print. Probably didn't save any time. LCD print, and then we're going to have it say our 8-ball says, close that off, and then our second row, our second row will give us the response from the Magic 8-ball. But we do want to set our cursor, and we're going to go to 0, 1 again. Just like up here, that's going to say Magic 8-ball says, and then from here it'll start our liquid crystal display. Alright. Now, we are done with this. We still have to go further into it, and we're going to use, you may have seen it light up as we're naming variables, but we're going to use the switch command. We haven't used this before, but it's going to switch reply, and we need to have cases that correspond with this value. Now, this is a little, if you're new to programming and you're not really sure how these softwares work with these integer values, this is going to be a little funky. Because we have it in a range from 0 to 8, we are going to have cases that go from 0 to 6. Now, basically what that's saying is, in a range of 0 to 8, I'm going to go ahead and make a comment over here. In a range of 0 to 8, it's looking for the integer values between that are greater than 0, and it's less than 8. So, and these are not greater than or equal to. So that means that we have the options 1, 2, 3, 4, 5, 6, and 7 available to us. Now, that is 7 numbers right there, but we aren't going to have cases labeled up to 7 because counting starts at 0. So we're going to have case 0 going all the way up to case 7. This is just a comment line. If you don't want this comment line, you don't need to have it, but I like to just kind of have that there to help me understand what this is saying, because it feels weird. And we have random through 8 here, and then we're going to have 7 cases, but it only goes up to 6. So, and we have that out of the way. Let's start naming our cases. This is going along with the switch function. Our first case is our case 0, and basically what it's saying is LCD print, and then whatever our first option is, we can say yes. The first thing the LCD, like the first option, will be yes. And then we're going to break. We are done now. This is done there. So this should be indented in. And there we have our first case. That's it right there. I'm going to copy that, and I'm going to come down here and paste it a bunch, because I don't like typing a whole lot. I'm lazy, and that's all right. So I'm just going to come down here and change all the cases. We have I can't count. 1, 2, 3, 4, 5, 6. We have our 6 cases here, and now we're going to change what our words are. We'll say most likely. What's something else they say? Outlook good, I think. Unsure, a little neutral, and then we're going to start going less things, less likely. We'll just say ask again, I guess, and then not likely and no. You can have these set to whatever you like. If you want to have a yes man 8-ball, you can set them all to something positive if that makes you happy. But I'll just go ahead and keep these very a nice even array. Now we're going to close up all of our brackets. We have 1 here on the switch reply, 1 here on the if statement, 1 here on the other if statement. We're going to come right here. After all this nonsense, we're going to, you may have forgotten about this, we're going to set our previous switch state equal to our switch state. Basically, after our switch state has been read, we read the switch state, and then it sets our previous switch state to that one. And that way it just keeps it updated, and it's not just saying previous switch state is always 0, because we have our main logic right here. The first conditional to get all this code working is if the switch state is not the same as the previous switch state. And that is all that we have for our code. So I'm going to go ahead and start simulation. I don't get any errors, so that's good news. If you have an error in your code and you hit start simulation, it won't start. But we have our 8-ball here. It comes up on the text. Now to get this to work, we have to shake our tilt sensor. So if we bring it up here, now our sensor is on high, and our previous is on low, essentially. We'll say 1 for high and 0 for low. Right now, our switch state is 1, previous is 0. If we come down here, it started. It went into the loop. Our previous is 1, and our current is 0. But remember, we have when our switch state is on that. If we come back down, gives us our answer, most likely. So it's a little weird right here with this little slider, but if you just kind of like, imagine if you were shaking it, and you had your breadboard here, and you just kind of, you shook it down, and then you shook it back up, you know? So, not likely, ask again, that'll look good. So, it's a lot more on the circuitry front and trying to think through what does all this nonsense, how does that connect to the breadboard, how does that connect to the circuit board, and then how do we get our code to have it. Like I said, you can change your stuff here. If you wanted to, we could make this our something to do with, you know, how our Rocket League is going. Just quickly stop in here, and I'll say, you may see where I'm going with this. Like our last programming challenges, we had that predictor. We have our cipher, we have our sage, we have our phoenix, and we have our omen. So now our magic 8-ball isn't telling us an answer. It's like a yes/no affirmative answer. Now we're getting a which team's gonna win. So if we take our initialize it as magic 8-ball. Magic 8-ball, who will win the tournament in the next day? It says Sage. That's pretty accurate. If we ask it again, like who will win the bronze division? We took ours up here and down. Phoenix, I think that's rigged. Hang on, yeah, there it is. Cipher, yeah, that's accurate. So that is there's a lot that you could change this and have this sort of random reply sort of info that you can have on your future projects. That is all that I have. Thank you for stopping by, and I look forward to the next week, where before we come back next Wednesday, we will continue into the off season, and I will assign the next project. It'll likely be project 8. I will assign that in the Discord and give you the information there.